All right, everyone. Thank you all for joining us today on our first webinar on our bridge design workflow. Doing just a little mic check. If someone can write in the chat if they can properly hear me. Okay, superb. Thank you. So just as a reminder, everybody is on mute today. So if you have any questions, you can write them down on the appropriate section of the Zoom interface, and we will try to answer all questions in the Q&A section at the end of the webinar. And if some questions are left unanswered, we will follow up on an email with all attendees. That might very well happen because we have a lot of topics to go through today. So without further ado, I'll just head on the agenda. So first of all, a brief presentation of SolidCAD today, who we are. Afterwards, we will go into InfraWorks for bridge workflow, following up with Inventor for custom bridge components, and finishing the presentation with Revit for bridge detailing. So brief presentation of SolidCAD. So as many of you know, SolidCAD was created in 1996 by Michael Cugin. And the company quickly distinguished itself as a leader in Canada in the field of computer-aided design by acquiring several companies until 2017, where Cancel and SolidCAD came together to form the company that we know today, SolidCAD, a Cancel company. So today, SolidCAD is the main Autodesk partner in Canada. We are the only Autodesk and Bluebeam Platinum partner in Canada, and we have a growing team of over 100 employees. So the industries that we cover, well, at SolidCAD, we specialize in technologies that support multiple industries, including architecture, engineering, construction for buildings. We also support civil infrastructure, manufacturing, plant, and media and entertainment. And we are an Autodesk authorized training center where we're employing the largest team of industry technology experts in Canada. And we're doing this in all time zones from coast to coast, and of course, in both official languages. So what we do, well, we help our clients to implement technology with computer-aided design and optimize their workflows. And we do this at three different very important levels. The first one at the design level by helping to make design creation more efficient and provide also data accuracy. We also do this at the management level with project management by helping to comply with industry standards and protocols. And finally, at the sharing level, in order to share data and project by facilitating collaboration, coordination, and communication with all team members and collaborators, whether they are internal or external. And in our civil infrastructure services, we do many different types of services. Training, consulting, of course. We also have teams of programmers and developers that can customize existing solutions, create totally new solutions for our customers, or also integrate with existing solutions in our client's environment. We also have a team of data management for management of your data and documents. And we can also do some workflow assessment and optimization. And of course, we held many events like the one today, but of course, all our events are currently all only online due to the current pandemic. Now, in terms of partner products, at SolidCAD, we have put in place several partnerships that is allowing us to offer the most recognized products on the market for our customers. One of the main partnerships that you all know of is Autodesk, with solutions like Civil 3D, InfraWorks, Revit, Inventor, which we'll briefly present today. Another partner that we have is Bluebeam with its solution called Review, which is a PDF creation, markup, and collaboration technology for design and construction workflows, which was developed by architects, engineers, and construction professionals. We also have a partnership with CTC Software with their productivity packs for Civil 3D and Revit. And another partner really interesting right now with Safe Software and the solution called FME, which is really used in the to bridge the two worlds that are the GIS world and the CAD world, for instance. FME is a data integration platform that would help to connect your system and transform your data and also automate workflows. So at SolidCAD, we have 15 offices and 12 training facilities across the country. And we offer two types of training options. One of them is the open enrollment training, which is open to all students with predetermined dates and are technically conducted at SolidCAD training facilities. And we also have the custom training option, where a curriculum is tailored to meet your requirements and goals. This type of trainings is normally performed on site at our clients' facilities. They are also sometimes performed in our own training facilities or online. But again, due to the current pandemic, all training is provided online exclusively. And in speaking of working from home, SolidCAD has a variety of services and tools to support clients who may be experiencing challenges while working remotely, and we can help by mentoring, consulting, and training on those existing platforms. We can also help implementing some of those remote solutions, or sometimes even customizing them. Now, for the topics today, we will first and foremost go with the introduction and talk about innovative workflows. So we'll be focusing on 3D model, highly adaptable bridge designs. Afterwards, we will look at the early stages of design in Civil 3D and InfraWorks, where we'll be setting up the design context in Civil 3D and InfraWorks. Following in Inventor for model detailing, and finally heading to Revit for detailing bridges. Now, about the speakers today, so we have Jay Kwan, technical consultant in the same team as I in the infrastructure team at SolidCAD. We have also Michel Beaulieu, a business developer who is working pretty much on all the teams here at SolidCAD, so the AEC manufacturing and infrastructure team as well, and Patrick Simic from our AEC team as well. So without further ado, I will leave it to my colleague Jay, who will kick off the main presentation. Jay?
All right, thank you very much. Okay, so let's start with an overview of the different bridge design workflows that are currently available. Okay, so I'll just briefly mention the traditional workflow, which is AutoCAD-based approach. Basically, you're creating a set of 2D plans. The challenge with this approach is ensuring that you have the latest designs in all your documents. Two newer sort of workflows have have been developed recently, which is one of which is based in Dynamo and the other InfraWorks. So the Dynamo approach relies on visual scripting. It's very flexible. Really, there's no limit in what you can do, except you know, there's a learning curve associated with it. The more you want to do, the steeper the learning curve is going to be with Dynamo. So what we're going to be mainly talking about today is InfraWorks. It has an easy learning curve. It relies on familiar tools like Inventor and Revit. And at every stage of the way, it's very easy to visually communicate your design. Okay, so this is sort of a broad overview of the InfraWorks based bridge design workflow. So in this center are sort of the core platforms or core softwares that we use. Civil 3D is involved in the early stages with base plan setup and design. Road design, InfraWorks is sort of in the center, with the creation and editing of the bridge. And Revit kind of comes into play when it comes to detailing and plan production. So we can also rely on Excel to do some bridge editing, parameter editing in a tabular format, and we can also rely on Inventor involved to sort of bring in custom bridge components. And we can use 3ds Max or other rendering software to produce high quality renderings beyond what you can do in InfraWorks. So let's take a look at the Civil 3D, GIS, and InfraWorks in early stages of design. So you're going to you're going to start the project in InfraWorks. Create a model either in Model Builder or a blank new model. So Model Builder is great in that you get a lot of contextual data very quickly. Things like aerials, buildings, water, terrain, and roads. Now, if you already have all that data, you might as well just create a blank model in a new model. So you do less cleanup of the model builder data. Also, it's sort of the preferred approach for 2021.0 and earlier, because Model Builder builds its models in LL84, Geographic Coordinate System. Now, as of 2021.1 update, they've kind of addressed that. So now we can create Model Builder models in any coordinate system of your choice. So kind of get the best of both worlds. Now, Civil 3D gets involved in four broad areas. One, reviewing GIS data. Two, converting survey data into GIS and surface refinements. Number three, preparing a topographic surface. And number four, designing road alignments and corridors. So as far as reviewing GIS data, InfraWorks has a very particular way of bringing in GIS data. It has its preset sort of properties that you can associate the source data properties with. Now, in order for you to map these properties, it's handy to actually view the source data, and that's easiest in Civil 3D. So you can do that there. And you can create additional properties in InfraWorks if you need to with the Add Extend Schema tool. Now, if you use ArcGIS connector to bring in your GIS information in InfraWorks, the schema mapping is sort of automatically done for you, so you can save some time if you go that route. As far as processing survey data, it's the usual survey stuff, importing survey points, creating a survey topo surface out of it, generating line work so that you can use it as a surface break line, as well as sending over point and line information to InfraWorks for use there. Now, to do that, you want to export the lines and points as shapefiles, because while you do have, while you can bring in DWGs directly in InfraWorks, as far as plain AutoCAD objects are concerned, it sort of behaves as a raster overlay, and you can't do much with it. So just use a map export command to send information out as shapefiles and then bring them in to InfraWorks that way. Okay, preparing topographic surfaces. Civil 3D has great tools for preparing surfaces, all sorts of data type you can bring in. Plus you have various build options, and you have full control over its operation type and order. Now, when you're ready to bring that surface into InfraWorks, a number of ways you can do that. You can open a DWG directly, or you can export then import a land XML, or you can export then import a GeoTIFF file. If the surface is of any significant size, you probably want to go with the GeoTIFF route because of the file size. So in our sample project, the GeoTIFF was about 4 megabytes. The DWG was around 50, and the land XML was around 170. Design alignments and corridors in Civil 3D. Well, you can actually start design in InfraWorks if you wanted to design component roads in there. And you can certainly bring it over to Civil 3D. The latest option to do that is the open model command. Couple advantages of that approach over the older export then import IMX, in that you can basically pick and choose all the parts you want from any proposal from InfraWorks. So that's a nice option. Now, if you're setting up multiple roads or alignments, it's probably easier to do it in Civil 3D because you have all sorts of tools that you can that'll help you, like construction lines, object snaps, and you can go pretty in depth with the subassembly composer if you want to build entire corridors and then bring it in. So a couple of approaches: you can open the DWG directly to bring in those objects into InfraWorks, or you can export and import IMX. They're both pretty similar. Open DWG is probably the more direct route, and export import IMX is probably more suited if you want to formalize the staging of the data, sort of the transfer process. Okay, so I'll go over a few of the InfraWorks bridge design features with you. Sort of broadly divided into creating, editing, analyzing, and sharing bridge designs. Okay, so to create a bridge in InfraWorks is fairly easy. You just run the command, pick the start point and the end point. You can just pick the points or type in the stations or lengths. So either way works. In this case, I'm just putting in the stations. Once the bridge is in, you can sort of, well, there's a number of bridge templates to pick from out of the box. You can create your own later, so we'll kind of take a look at that as well later. Once you choose a template, you can do things like change the number of piers. I'll switch it over to 3 piers in the setup. Adjusting, like repositioning the piers and changing the skew is fairly easy. There's all sorts of properties that you can enter in the box, in the property palette. And yeah, those are all the properties that have been basically made visible by the model. So for each bridge component, you'll be able to control, you'll have a lot of control over how it's set up. Now I'll select the girder group and then girder. So because of the template that was on the NASHTO, I can select, I can just select the girder and choose a Canadian style. I'll choose one of the CPCIs. And you'll notice that it has these blue sort of section planes. If you click on any one of them, you can sort of create a new plane of your own as well. So here I'm creating an orange custom sort of section plane. And at each plane, you can sort of adjust the parameters as well. So in this case, I'll change the depth to 1.2 from 1.4. And then you'll be able to visually see the change. And you don't have to change each individual one by one. You can just apply one configuration to all the rest in the group or the entire bridge. So that's fairly easy to do. Next, let's take a look at the style palette. Just take a look at how it's set up. So earlier we saw all sorts of sizes for the CPCI girder type. If you take a look, it's really just one model with different variations. Now I'm just going to create a duplicate because I'm going to make some edits. So I just created a duplicate of the CPCI. And if I take a look under the part sizes tab, you'll see various columns representing the different data configuration. You can easily add your own column. So I'll just add, for instance, I'll just add a 1500. So that's fairly easy to do. Just add additional configurations of existing design or your own model. Once you have changed any of these settings, you can easily export them to a JSON file so that you know, you can use them in other projects and that kind of thing. Also makes for a quicker recovery if you happen to need to reset things. But yeah, you can easily import the JSON after it's been exported. Okay, so and now if I go into the list, we'll see a 1500 that we set up under the CPCI custom category. So there are a lot of parameters to edit. You can actually send it out to Excel to edit those parameters. Each component group sort of has its own tab or worksheet, and any of the blue values you can change mostly as a rule of thumb. And you can use autofill features. I mean, just it being in Excel opens up all sorts of possibilities as far as linking them with formulas and things like that, just to make it easier to edit things in a group. Okay. So once you make an edit, you can update the design from the spreadsheet. And you can also, once all your components have been set up, you can just create a new template so that you can reuse a design on other bridges or future projects, whatever you might need it for. Okay, so let's take a look at some analysis. Here I'm running the line girder analysis. So it has some pretty nice analysis tools for some quick analysis. So once that's done, I'll just open the output folder, and it creates a bunch of PDFs for each girder with all sorts of information on it. We also have the refined analysis tool as well. This is a more recent tool. Maybe just one page worth of setup that you can sort of check. Now, when you run that, it just does an analysis on the entire bridge, and you can just, it also creates a PDF report that you can review. Okay, so InfraWorks has a lot of, as I mentioned, it's very easy to visually communicate your design. So here I'm just creating a snapshot of a view. So you can just output a view to a JPEG file, which you can email or whatever you want to do with it. You also can easily create videos. It's fairly easy. Just set up a camera path, start point, end point. Pick the length of the video clip in seconds and just export that into a video file. And that's fairly easy to do. So I'll just open up the output, just take a quick look at that. And there's also the shared view option. Now what this does is it basically creates a model, a cloud model of your design that you can view in just a web browser. So it generates a link that you can send in an email. Also creates a hyperlink that you can click to take a look at it yourself. You can do measurements with snaps. You can also do markups. So here I'll just do a cloud markup with a quick arrow and some text. Now the nice thing about these markups is that it's sort of like tracked as an item. So when you save that, it goes into the comments panel. It's created as an item with a link that you can copy. And once the issue is resolved, you can click on the resolve button to basically mark it as resolved. Now, if you need to do higher quality renderings, you can export the entire model as an FBX. So that's what's going on here. And essentially that lets you send it over to 3ds Max or Lumion or whatever else you need to do. And when you're basically ready, you can publish your design so that it creates an IMX, but also a JSON file and a log. So the JSON especially is important to sort of coordinate with Revit. And you can also just update the design and just overwrite the IMX file that you created earlier if you need to update your design. Okay, so let's just do a quick review of what we kind of covered. So we took a look at the early design portion in the Civil 3D. So basically creating the base plans and the road alignment and corridor. Then we kind of took a look at the InfraWorks capability, and as well as sending out some information to Excel for easy editing, and sending information out to a rendering engine for more higher quality renders. So next, we'll sort of take a look at the Inventor portion and bringing in custom bridge components. And Michelle's going to cover that topic for us.
Thanks for the details, Jay. Greatly appreciated. Just going to share my screen here. So let's move into the custom bridge component of the demo using Inventor. When it comes down to creating the components with Inventor, you basically have two approaches, two choices, if you will. You're either going to start from scratch, create a component, or you're going to do some reverse engineering. Now, for the purpose of this demo, I'm going to be using the reverse engineering method. Now, either way, you will need to be aware of the InfraWorks required parameters. The required parameters are the names of dimensions inside of Inventor that InfraWorks is going to look for and want to control. This slide is a small list of bridge components and their required parameters. Note, there are additional parameters that Inventor and InfraWorks can use. Even if they are not required, they could be referred to as essentials. A good example of that is the pier cap top left slope in percentage. Yeah, it's a mouthful, but it's an essential parameter. Now, using the reverse engineering method simply involves a copy and edit, or if you want, simply an edit of an existing style inside of InfraWorks. And then, of course, you're going to save that style, that model, as a different Inventor model. So you might wonder why Inventor. As you know, InfraWorks is a great parametric modeling, road modeling software. However, it's not a detailing level parametric modeling software. Inventor is. Inventor's been around for more than 20 years. It's an extremely robust and stable platform and has a very simple user interface for creating 2D sketches and 3D models. Once the model is finished, inside of Inventor, you're simply going to publish the model to InfraWorks. And to simplify that task, Autodesk created a plugin for Inventor. Of course, the next step is going to be to import your Inventor published file inside of InfraWorks. And to do that is extremely simple. To use the Add New Style button inside of the Style Properties inside of InfraWorks. Now, one last thing I want to point out throughout this demo, not all models are created alike. Inventor has the ability of creating single body parts, multi-body parts, as well as assemblies, which is a collection of parts. This is going to affect your Revit model and the detailing. The images on the right are a good example. The single body merges the casing with the foundation, while the multi-body or the assembly will keep them separated. So a better Inventor model will create better Revit detailing model. So let's get into a short demo and show you how easy it is to create a custom bridge component. Now, this demo is actually going to start from the InfraWorks. As I mentioned, I'm basically using the reverse engineering approach. So one of the easy methods inside of InfraWorks is if you go to your style palette, pick one of your existing piers, and the software will tell you the name of the pier you're looking at. I'm using the Enhanced Standard Pier. So going to my parametric model, I'm going to go into my bridge for my components. And in this case, I know I'm looking at piers, so I'm going to look at the different piers that are available. Now, I can see here the very first item is the enhanced standard pier. So all I'm going to do is I'm going to go ahead and proceed and edit that pier. The pier, the window dialog box comes up, and here's the key. You'll want to use the View in Explorer. When you click on that button, it's going to show up this folder. This is everything that's required to control this pier. And what I have is this geom.ipt. This is a Autodesk Inventor file. All I need to do is, now I'm going to point out, you don't want to rename these, you don't want to mess around with them, but I can double click on that file to open it up inside of Inventor. Once it's open inside of Inventor, I'm simply going to go ahead and save this as a separate file. So I'm going to do a save as. I'm going to save that in my workspace. Now, I will point out that I'm using Vault. I'm not going to get into all the details of Vault and everything that Vault may be. You don't necessarily need to use Vault. I use Vault because I'm a little bit, let's call it OCD, if you will. Some people like the fact that I'm OCD and some people don't. I'm going to leave it as that. So moving on with my Inventor model, I'm inside of Inventor. I can see my model. And I was talking about parameters. So what are these parameters? So here's a good example. Now, I'm looking at a list of parameters, and I can see, for example, there's a parameter. Remember the required parameter? The pier height is a required parameter. So I could be looking through my model inside of this model of all these sketches and everything else. Where is pier height? Where is it hiding? How do I find it? How do I go modifying it? Well, if I know my parameters and I know how to control them, I can simply type it in. What if I want to make this 15 meters? What happens? I can see the updates immediately. Okay, let's send it back to 22 meters. That's fine. So up here, I can see this one called the desired number of pier columns. So that's obviously not a required parameter. However, I can, if I want to, start to control and change and manipulate the number of columns that I might have. However, I may want to make it a little bit easier for my users, and basically what I'm going to do is I'm going to create a multi-pick list so that inside of Inventor, instead of giving them the option of typing in whatever number they want and making a mistake, they can simply pick how many columns they want. So it makes it really, really simple. All right, so I'm going to go back to a single pier in this case. Now, I can even go a little bit further, and I can go in, for example, for the pier height. I could say that inside of my comments, I'm going to put a note. This is the total height. If only I could spell, of the pier. What happens with the comments? They will show up inside of your tooltips. Now, obviously, this does not create, at this point in time, a custom model. I am in the process of customizing it. I'm actually going to go a little bit further. Looking at the design, the engineers decided we need a stiffener. So I'm going to go ahead and I'm going to start to sketch a very simple 2D layout. And you're going to kind of recognize, I'm in my sketching window right now. And if I start to look at some of the icons, you're going to kind of recognize these icons, lines and circles and arcs and rectangles. So for my stiffener, I'm going to keep it simple just for, let's call it purpose of time at this point. And I'm going to go ahead and I'm going to do a very simple little rectangle down at the bottom. Now, I'm going to put a fixed height. I could make this a parameter so that I can control the height and everything. But in this case, I'm making this fixed. I don't want people to start playing around with it. So I'm going to make it exactly 1 meter. And for the width, I'm going to go 0.5 meter. Now, the only thing I'm going to need to do is I want to basically locate the bottom of that to be at the bottom of my pier so it doesn't move. That's where it's always going to be located. I'm going to finish my sketch. And the next step is basically creating a 3D model, or what we refer as a feature. I'm going to go ahead and extrude that lovely profile. And what I'm going to do here is I'm going to extrude that profile between this face and this face. So you'll see that basically the model identifies the faces. It starts to extrude. I don't have to give it distances. If the distance between these faces change, the model automatically updates. I do know, however, that it's doing a full circle all the way around, so I'm going to tell it to calculate to the minimum distance instead of the maximum distance. Now, remember when I talked about the single body and the multi-bodies? So when I open up this model and I look at it at first, if I look in my browser, I'm going to see that this is referred to as number of solid of bodies, and there's only one. This means that if I continue with this object as is, it means the cap, the columns, and the stiffener is going to be considered one single pore. It's not going to be separate pores where you're going to have construction glue and joints and so on in between, all right? Now, this was started as a single body. I'm going to leave it as a single body for now. But if I want to make my stiffener a multi-body, all I got to do is click on this little button that says create a new body. It's that simple. That's all I have to do. It's a toggle switch. Now, in this case, I'm going to keep it as a single body. All right, so I'm going to say my model is done at this point in time. So I'm going to save this. And remember I said to export this out, all you had to do is go into the environments, go to your infrastructure button, and click the export button. Now, I will point out that Jay is located in Moncton, New Brunswick. I'm in Fredericton, New Brunswick. Patrick is actually in Quebec. Patrick is actually in Ontario, and we have Maxime in Quebec. So we are literally spread across Canada. So when we're working on these projects, we actually use the Autodesk BIM 360 because it allows us to be anywhere in the world and connect to our data and keep sharing that data and working. So I'm going to publish this into my peers, and Jay on this side would be able to import this into his InfraWorks model. But for purpose of time, we decided that that was going to be my task today. Apparently, I need to start learning a little bit more InfraWorks, not just Inventor, but a little bit of InfraWorks as well. So I'm going to go ahead and export this. Now, I've done the demo more than once, so I apologize. I forgot to erase that file. It already existed. I just exported a new version over the previous one. That's actually the process that we take to update the models. Now, with that said and done inside of Inventor, I'm going to close this. And if I go back to my InfraWorks, I'm going to close this window. And remember I said in my style palette, all I needed to do was now basically add a new style. So I click on the add style, and I'm going to go browse for the style. Now, the style I'm talking about is that style that's in my BIM 360 folder under my peer. So there's my peer that I just created. I'm going to bring that in. There's the required parameters. I needed to make sure I had peer height, peer cap left width, and peer cap right width. And I know that this is my part because if you look at the icon at the bottom, you can see that little stiffener down here at the bottom corner. The software, InfraWorks, reads the peer that I created, recognizes that it's a peer, and automatically assigns it to the bridge domain, and it assigns it to the component type equal to peer. Now, it could have multiple component types, but it's smart enough to recognize that this is a peer. If I go to my part size, basically I could be adding columns for specific settings, as you've seen Jay do. In this case, all I want to do here is I want to give it a, let's call it a better name for the lack of something else. I'm going to go to my user interface appearance. Now, this is where, as a InfraWorks user or an Inventor user, you may want to spend a little bit more time and clean up what the InfraWorks users are going to see. So, for example, desired number of peer columns. As a default, the parameter names cannot be changed. However, what Autodesk has given us is a label. We can make the label look like or say anything that we want. So I can start to clean this up just by adding some spaces so that these parameters are a little bit easier to read, if you will. All right. Now, remember I said that if you put in a comment, it shows up in your tooltips. Well, remember that peer height? There's the peer height. It shows up. The comment that I put in shows up as a tooltip. So the InfraWorks user will hover over a parameter and say, gee, I wonder what that's supposed to be used for. And there's my tooltip. So I can tell them, I can give them messages of how they're supposed to use this. I can control which variable is visible, which variable can be modified. For example, has a round column. So I could control the label here. But the other thing here is I say an integer. What does that mean? Well, the InfraWorks user might not know what that means, an integer. However, I can turn that into a toggle. Making it a toggle means it's an on-off switch. It means that either it's going to have round columns or it doesn't. Now, the next thing you may want to do is clean this up by grouping your parameters. So for example, I might say that the number of columns should be under columns. The round columns should be a grouping of columns. And when I'm looking at pier caps, well, pier caps should be maybe under caps. So these will be groupings that are going to show up in my palette over here on the right-hand side. Now, if you're like me and you create a lot of piers or a lot of custom components and you find that, hey, you know what, I'm always using the same parameters, they always have the same name, and I always want to control them the same way, well, you can save yourself some work. If you've done all these settings once and they work and everybody understands them, you can export those settings to a file. And then later on, you can import them again. So I actually have one of such settings that I'm going to go ahead and import to save myself some time, because I'm sure you guys don't want to see me type. I'm not the best typist around. So let me go into my BIM 360 file, because this is a shared file that we use and import and reuse over and over again. And I'm going to go into my piers, and I'm going to bring in my pier. So now all the labels are automatically updated. My tooltips have been improved. My visibility is controlled. My parameters for whether the parameters can be modified or not has been controlled. Toggles have been set, integers and so on, and my group names have all been set. All right, so now I can go ahead, click on OK, and import that style, that custom component that I did inside of my InfraWorks software. Now, to assign it, you already saw how Jay assigned a girder. It's basically the same thing. All I do is I'm going to go ahead, I'm going to pick that model, and I'm going to go assign a pier, and it's going to be my pier. So I go ahead, I grab my pier 2, it assigns it, and the data comes in. Now, obviously, I don't like the size and values that were there to begin with, so I'm going to adjust my vertical offset. And I'm going to go ahead and adjust also my depth. And I'm going to adjust my taper. I'm going to go 1 meter with a 0.5. And I'm going to say I need 2 columns. I'm going to go with a spacing of 4. And my width is actually going to be 1.8. And the depth, I'm going to go, let's say, 1.2. And I press enter. And it updates the model. Now, you may want the columns to be a little bit skinnier. That's fine. You may want the spacing to be a little bit skinnier. That's fine. It's just a matter of finding your parameters, adjusting the values. Remember the groupings. So there's the groupings for my columns. So all of these parameters apply to my columns. So in this case, I'm going to go ahead and adjust my width to make that a little bit skinnier. I'm going to go 1.2 and let's say 0.9. All right, now if I zoom in on that, you can see that is my column that I started from the enhance. I copied it, modified it, added the stiffener to it. It's that simple. The next part that I want to talk about is the difference between a single body versus a multi-body versus an assembly. So remember when I created this one, this was a single body. Well, I'm going to use another model that I've already pre-created ahead of this seminar. So let me go ahead and change this. And I created a single body pier. Let me load that in so you can see what it looks like. I'm going to go ahead, take this second pier, and I'm going to assign it another different pier. I call this one the multi-body pier. Going to assign it. You're going to notice that, hey, the first one kind of looks a lot like the second one. Can't really tell them apart. If I grab the third one, I'm going to make this an assembly. here's the interesting thing. Inside of InfraWorks, the user that is working with these will not be able to tell the difference. When I'm looking at this column with a cap, which is a single body, except for the name that I called it single body, if you look at all of the attributes that are in here, the cap parameters, the appears, material, the way it behaves and works, you can't tell the difference. There is nothing inside of InfraWorks that says multi-bodies react differently than single bodies, or that assemblies react differently than multi-bodies. Now, if you're done your bridge and you need to export this to Revit, you're going to want to create that IMX file again. In this case, again, as Jay presented and showed you, it's very simple. You simply select your bridge, and you're going to go down to Publish Your Civil Structures, and you're just going to update the existing bridge, and all you got to do is click on the Update button. Now, basically, I'm done this portion of the Inventor side of things. So I'm going to flip back to my slide deck, and really the next step is for Patrick to kick in, and he's going to go do the Revit detailing, the bridge detailing. All yours, Patrick.
Thank you, Michelle and Jay, for the good information. So the final step in the workflow design is going to be bridge detailing inside of Revit. So we're going to go through a couple slides and a quick demo showing the different options within Revit itself. Importing InfraWorks data into Revit. Previous workflows of importing data from InfraWorks to Revit and modifying design has changed. Old workflow was you design in InfraWorks, export the data directly to Revit, and modify design and detail within the Revit environment. The new workflow is you still design in InfraWorks, you export the data, but you import it within Revit. Any changes, you modify the design in InfraWorks and re-export the data back to Revit itself. Adding additional detailing, annotations, rebar reinforcement, and so on is done still inside of the Revit environment. Map Revit categories. So new categories to better support bridge design in Revit have been added. This feature supports the civil structures workflow with Autodesk InfraWorks and Revit. This update includes a new filter for the infrastructure category, making it easier to find and use infrastructure-related categories. Prior to importing the bridge design files, you can verify the data. Once the bridge design has been imported, we could verify the data closer by selecting the elements. Parametric data from InfraWorks will be present inside the Revit environment. The way elements are created within InfraWorks will be designated by a part type parameter in Revit. Single body versus multi-body versus assembly do import differently within Revit. An assembly part type is the recommended option as you gain more control of individual elements to add additional detailing. Modifying design. So as mentioned, to modify design, this will be done in InfraWorks. Parametric data is modified within InfraWorks and exported out. The link between InfraWorks data and Revit data will check for updates. Reinforcement and detailing. Once the data has been updated, additional reinforcement and detailing can be done within Revit. 3D views, sections, etc. are created within Revit. From these views, annotations and rebar reinforcement can be added. Revit Annotations. So using the Annotations tab inside of Revit, dimensions can be added to the views. In addition to dimensions, detail lines, regions, and components can be applied to the model for further detailing. Revit Reinforcement. So rebar reinforcement, like rebar hooks, etc., are also applied to the model for detail. The typical approach is to use the native Revit reinforcement tools. Freeform rebar is a great way to add rebar to unique shapes that come from the bridge design. So let's get into a quick demo. So new to Revit, we have the discipline infrastructure with 26 new model categories along with 20 new annotation categories to help streamline the InfraWorks to Revit workflow. When inside of Revit to import your InfraWorks models, you are going to be needing to download the civil structures add-in. And then from here, we are able to import the IMX file, which should be placed with a JSON file and the text file exported from InfraWorks and using the import civil structure. Prior to importing it, you can then categorize or map the categories from InfraWorks into Revit, which from here we will see then a large list of different options we could categorize different categories from InfraWorks back into Revit. Once we have that all verified as mapping the categories, we can then verify the data itself. So here we have the bridge model that we saw before being shown, starting with the first pier foundation. By selecting this, we can see we're selecting it as a whole. And in the properties, we see all the different parameters that are associated from InfraWorks back into Revit. Also, scrolling down, we can see a part type that was established inside of the InfraWorks model, giving it a single body option. Moving our way down to the next pier foundation. Here again, we see elements joined all together, having the parameters found in the properties to the left, and also a part type established as the multi-body. The last one, as we recommended to have an assembly as the main detailing or the main import, we can see now the individual elements come as single items. With this one, you have more control over the individual items and also the detailing features. Any modifications done to your bridge design, this will then be done inside of InfraWorks. And when an update is being added, inside of your add-ins tab where the civil structures is, if it is a live update, you will get a pop-up dialog box if you want to accept or ignore the update at the time being. If you ignore the update, you could always come back down the road into the civil structures add-in and select check for updates, which will prompt you once again the same dialog box as you would see if a live update has happened. So adding extra reinforcement and detailing to your bridge design can be done by creating certain and specific views. Starting with a floor plan of our structure, here we can see the 3 different piers and pier foundations with a couple sections through them. As Michelle mentioned, single body versus multi-body and assemblies, they do affect the way that they come into Revit. Starting with this first pier foundation and pier, going into that section, we can see graphically how the pier and the pier foundation appear. There's missing detailed lines, and also it is coming as a single element that we have. If we go now to a assembly, so back into here, and the last one we had as assembly option, we could then start to see the different ways that graphically the bridge design will start to appear. First, extra detailing as we have the elements being as separate components, and a lot more detailing that can be added. Within our detailing options, we can start to add dimensions. So inside of Revit, we got our Annotate tab, align tools for the dimensioning. So adding extra detail to our bridge design. Along with the dimension tools, we have spot elevations, which are crucial with bridge design since we definitely need to know where all the different values of the level and elevations are of the bridge itself. Along with dimensions, we do have detail lines, filled regions, and components. So components are great tools to add additional detail to our drawings. So again, with this detail component, I'm using a family, which is a key, to have that connection from the cap to the column and having that value there. And in the end, we could always add a tag to give it a more descriptive item. Still with the Annotate tab, we have a large list of different annotating tools, and symbologies can also be added to our views. Inside of the symbology area, I could do a center line and adding that leader to the view. So once we added annotative details to our design, we could still move it even further by using Revit Reinforcement tools, adding the rebar. Great tool inside of Revit. Not only can you do it from sections or plan views, but you can also do it from a 3D view using the freeform rebar tools. So selecting the pier as we have in place, I can have it selected, go into my rebar reinforcement tools, and at the very top, we can see we have the freeform rebar. 2 types of distribution options, aligned and surface, which makes it a lot easier to use to those unique shapes within a bridge design. So by selecting a couple of these options, we could then start to specify where we'll like to add that detailing to. And once complete, we could start to add that rebar to our structure. So again, from a 3D view, we could add the 3D form rebar. And once we have that one completed, going back to our specific views, like the section that we saw before, and adding additional emails like a tag to our view itself. So again, a quick little demo within the workflow inside of Revit. And if I go back here, that would conclude the workflow from the beginning to the end and having our webinar concluding here. So we'll kind of let Maxime come forward with the questions in regards to our webinar.
Yes, thank you, Patrick. As of now, we have no questions. So if anyone has any questions, you can always ask them inside the proper section in the Zoom interface. We have another 2 minutes before the end of our presentation. So if anybody has any questions that they want to ask to us, you can do it for the next 2 minutes. Otherwise, you have our contact information, so you can always ask the question directly to one of us, and we will gladly answer them.